Welcome back, students. In the last part, I told you that there is something related with the stability, right? It's not only about the inductive effect, it's not only about the mesomeric effect or electromeric effect, but the role which hyperconjugation plays is a role which it plays in the unsaturated bonds, p pi bonds and sigma bonds. So that we'll be learning here about the hyperconjugation. Here, let's proceed. Now, students, we are going to learn one more effect, okay, which is responsible for checking out the stability of unsaturated system or the pi bonded systems. So that is my hyperconjugation. Now, what is this hyperconjugation? It is a general stabilization interaction, that's what I said. Now, it involves the delocalization of the sigma bonds. Delocalization of the sigma bonds of the CH bond of any alkyl group, whether it will be CH3, C2H5, C3H7, any of the alkyl group which is directly attached to an atom of unsaturation system. Unsaturation means what? It will be either of double bond or triple bond. Okay, a double bond, the triple bond, or to an atom with an unshared p orbital, means which will be having a vacant p orbital. If I have the delocalization of sigma bonds to it, then I say that this effect is a hyperconjugation effect, and this is a permanent effect. It's like this. Now here you can see that I have a triple bond between here. Okay, these are what sigma bonds, and between those triple bonds, what will happen? This will travel. These are what vacant orbitals. So it may be the case that this bond travel this way in the vacant orbitals. So this is called as hyperconjugation effect. So again, it's the permanent effect. Okay, it's the permanent effect and unshared p orbital. So what happens if you have to check the stability? Like earlier, what we used to do, we used to have the inductive effect like this way, right? The more the number of carbon atoms, the more it will get balanced, right? The positive charge, and then we said it is more stable. But now you have to look at the more number of hydrogen attached to it, okay? Because then only C and H bond will break up. So if you have like now if you say that this is my CH3 and CH3 and this is my positive charge, is it stable according to the hyperconjugation? Then no, it's not. Because for it to be stable, when it will be more stable, it will be more stable if there is a H here. If there is a H here, okay, if even this is CH3, so this one is more stable, okay, this one is more stable as compared to the previous one, because there is a H here and this bond can break, okay, and go into the vacant p orbitals. So this is hyperconjugation effect. When this effect will come into the picture? Whenever there is a unsaturation. So keep in mind that unsaturation part. So students, here you came to know that your hyperconjugation effect, it is somewhat different than your it is totally opposite of your inductive effect. Okay, but in that inductive effect was only in the sigma bonds. Your hyperconjugation, you have to have your pi bonds or the vacant orbitals. That transfer you should have. Now in the next part, I'll be talking about the different purification techniques, because just like in metallurgy and inorganic chemistry, the organic compounds are also not very pure. So we have to purify it. That we'll be learning in the next part. Stay tuned with me.